Alright, so the next part says to describe the meaning of the x-intercept in this equation. So, if we're talking about this one right here, what happens at that point? What is going on? It's going to be completely empty. There's no more water in the tank. So, we're going to write that. There is no more water. I'm going to put H2O for water in the, what was it, a tub? In the tub. Okay, so this next part asks, let's use a different color. After how many hours will the tub have 10 gallons? So gallons is in our Y, so I'm going to find 10, go across till I touch it, and then down. So how many hours is that? 5 hours. And let me switch colors. After how many hours will the tub have 5 gallons? So I'm going to go to 5 gallons, go all the way across and down, and you said, what was it? 10. $10. Let me go over that with a pen so you can see it. And after how many hours will the tub be completely empty? 15 hours. Good. So our last problem for today is talking about a flower shop. So I'll give you a minute to go ahead and read it and highlight any important parts. If you're watching the video, you can pause it. Okay, so a flower shop. A customer at a flower shop has $30, so that's the most that they can spend. Flowers are sold for $2 each, so no matter what type of flower it is, it's going to cost them $2. The customer would like to purchase a mixture of daisies and carnations. How many of each flower can the customer purchase? So part A, write a function of the amount of daisies and carnations that can be purchased. Well, first we need to decide what do we want to call daisies and what do we want to call carnations. We can call them D and C, but let's use X and Y because that's what we're more familiar with. So let's make daisies X. So I'm going to put an X above daisies, and then above carnations I'm going to put a Y. So how much is one daisy? And how much is one carnation? Because it's $2 each. Good. So I'm going to have the equation 2x, and then I'm going to have a 2y, and that's going to be equal to $30 because that's the most I can spend. Now I need to put something in between the 2x and the 2y. So let's put a plus. Good. Because we need to add those together. Now whenever we are graphing equations, it's easier to graph if it's in slope-intercept form. Y equals mx plus b, meaning we need to solve for y. So if I'm going to solve for y, I need to get rid of this 2x first. So I'm going to subtract 2x on both sides, and I will have 2y is equal to negative 2x plus 30. Now the 2 and the y are multiplying, so I need to do what? Divide everything by 2. And when I do that, I will have my final equation, y is equal to negative 1x plus 15. All I did was I divided everything on this line by the 2, so that the y would be by itself. So they want to know, in this relationship, is this relationship discrete or continuous? So before you answer, think of it this way. Can you go into a flower shop and say, I really like that carnation. Can I only buy half of it? No, you can't do that. So it's going to be discrete. label the coordinate plane, graph the function, and identify the domain and range. Well, we said x is going to be daisies, so I'm going to go ahead and write daisies down here. Which means in my y directions, we're going to be talking about carnations. So now, in order to graph it, I know I'm going to have a max of 15 in the y direction. So I'm going to go ahead and go by ones again, just like I did on the last problem. So that's going to be 0, and I'm going to label every other one, just like I did on that last problem, just so that it's easier to read. And then I'm going to do the same for the daisies in the x direction. So I have that. So now if I want to graph this, what I need to do is I need to plot my y-intercept, which is 15. So 15's right here. And then my slope is -1. So I'm going to go down 1 and to the right 1. And we said this is a discrete relationship, so do I need to connect these dots? No, I do not. Good. So there's my graph, and I'm done. Now I need to determine what is the domain and what is the range. Now, since it is discrete, do I need to use my alligators, the inequalities? No, I need to list every single number. Well, writing 1 through 15 is going to take up a lot of room, and I don't have that much room on here for both the domain and the range. So what I'm going to do is I'm going to start off as if I was writing it out. So I'm going to go 1, 2, 3. But a shorthand, a way to shorten it is to put dot, 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 because it's going to continue that pattern, is what we're saying. And I know that I'm going to stop at 15, so I'm going to go back to 13, then write 14 and 15. So I know the reader of this would see is I'm going 1, 2, 3, so I'm going by ones, and it's going to keep going, and I'm going to end at 15. So that's a way to write it, so you don't have to write all those numbers out. So if I want to write the range, it's going to be the same thing. I'm going to go from, oh, I'm sorry, there should be a 0 in front of that one. 0, 1, 2, 3. And the range is going to be the same thing. 0, 1, 2, dot, 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 13, 14, 15. So they're both the same. Are there any questions with the domain and range? Make sure that you have 0 in there, because it is possible to have 0 daisies. So describe the meaning of the y-intercept, this part right here. What does it mean? How many carnations do we have? 15. How many daisies do we have? 0. So for the y-intercept, we have 15 carnations and 0 daisies. And the very last question is now asking about the x-intercept. What is going on right there? Good. 15 daisies. And 0 carnations. And we're done.